All right, okay. All right, so we continue this chapter, okay. Okay, so first kind of the classification of a carbon, okay. So if the carbon attach only to another carbon, okay, so this we call kind of primary carbon, okay. If the carbon attach kind of two other carbon, we call kind of the second carbon, okay. And if the carbon attach kind of three other carbons, okay, we call kind of the tertiary carbon, okay. If a carbon attach kind of four other carbons, okay, we call the quaternary carbon, okay. Right, so that should be easy, okay. So in this case here, for this molecule, okay, we use another little bit different color, okay. So these two carbon and okay, here and here, okay. The purple color labeled one should be the primary carbon, okay. So primary, okay, because they each only connect with one another carbon, okay. Right, and then for a little bit different color, okay. So this one, 3, 4, 5, 6, 8, 9. Okay, so this green one, okay, should be our secondary carbon, okay, because they are connected with another carbons, okay. And okay, it was red, okay. This one and this one, okay. So these two guys, okay, so that's the tertiary carbon, okay. So because these two carbon connected with three other carbons, okay. And in the end, okay, so we have okay, I have another color, okay, okay. The blue one, okay, right, this one is kind of a quaternary carbon, okay, quaternary carbon, the connected with the other four carbons, okay. Yeah, make sure you know there are kind of a difference, okay, and maybe in the exam one, I give you one molecule, okay, ask you how many primary, secondary, tertiary, or quaternary carbon, and maybe ask kind of show me and indicated, okay, so that's you need to do it, okay. And based on the carbon classification, okay, so we also can classify the hydrogens, okay, primary hydrogen, secondary hydrogen, and also tertiary hydrogen. That's actually kind of pretty easy, okay. So primary hydrogen, pretty much is C3, okay. So we just look at kind of what's carbon attached on this kind of the hydrogen, okay. So if the kind of primary carbon, this hydrogen will be primary hydrogen, okay. And if this carbon attached kind of secondary carbon, okay, so that will become kind of secondary kind of hydrogen, okay. So normally just kind of CH2, okay. So if this hydrogen attached kind of tertiary carbon, okay, so this hydrogen will become kind of tertiary hydrogen, okay. So normally just CH showed here, okay. There's no quaternary hydrogen, okay, because the quaternary carbon just kind of has only carbon bonded, okay, for bonded. Right, okay. So that's about the classification hydrogen and also the carbon, okay. And then now we move to the substitute the cycloalkene naming, okay, branched one, okay. So there's some kind of the substituent group on it, okay. All right, and so all substituent group will be as kind of prefix put before the kind of the parent ring name, okay. So cyclo something, okay. So if there's only one substituent group, okay, so so you don't need to give its location number, okay, because there's only one, okay. So everyone know it, okay.
I'd rather you be just a memory in one's head or something like that.
Okay, can you say that again? A question?
That's how I thought that.
All right. Okay. Cannot hear clearly. Okay. So if you have question, okay, please. If you have question, okay, please type in the chat window, okay, so that's easier for me to catch up you, okay. Yeah. All right. All right.
I don't know.
Okay, question.
I don't know. I did for a long time, but.
Key Hinterm, you're unmuted. Please mute yourself. Thank you.
Yeah, if you please mute yourself, okay. So so if you have question, type in chat window, okay. All right, we'll continue here, okay. So so if you have some kind of only one substitute group, okay, on the kind of cycloalkene, okay. So don't need to give a location number, okay, because doesn't matter, okay. So people know there's one substitute group on it, okay. Right, for example, this one, okay. Right, so the parent name should be called cyclohexene, okay. Right, So anyone know what's here the substituent group name for this one? Anyone know what substituent group knows this one? Okay, that's required substituent group name. That's perfect. Yeah, isobutyl. Better than this morning. Okay, so this morning none of them students know the kind of isobutyl. Okay. Isobutyl. Okay. So 4 carbon should be kind of butyl, something butyl. Okay. Yeah, we already know there's 1/3 butyl. Isobutyl is kind of end of the kind of the branch. Okay, end branch. Okay. So yeah, isobutyl. Okay. All right. So the full name for this molecule is called kind of isobutyl. Okay. Don't need to give location number. Okay. So if there are kind of 2 substituent group, okay, so then you need to give location numbers, okay. But yeah, there's come kind of the one problem, okay. So yeah, still show you guys here, okay. Right, for example, this one, okay. Okay, so yeah, the problem is kind of which one we give number 1, which one give kind of the second number, okay. For example, we can number is kind of 1, 2, 3. Also, we can number that's kind of this methyl group take 1 and then 2 or 3, okay, clockwise, counterclockwise, okay. And so that's come to here, okay. So we try to give the low alphabetic order kind of the substituent group, okay, lower number, okay. So that's similar like here the rule we learned in the chapter. Yeah. So who's talking already? Okay, we learned in the kind of chain numbering label case. Yeah. Use same distance, okay. So yeah, try to. Okay, so I have to.
What an asshole.
All right. Okay. So yeah, in this case here, here, okay. So yeah, we can see, okay. So the ethyl group start with E, methyl group start with M. Okay, so that means here we take here the block numbering, okay, because ethyl we have the lower alphabetic number, okay, lower alphabetic number, okay. Okay, so that's will become kind of the 1 ethyl 3 methyl cyclohexene. Yeah. So if there are 2 substituent group, okay, so you need to give their numbers, okay. So number depends on their name, okay. So the lower alphabetical order, the substituent group, okay, lower number, okay. Okay, and then if there are kind of the 3 or more substituent group, okay, so situation become another situation, okay. So we have different way to number it, okay. So we try to give the lowest set of total numbers, okay, for the all substituent group, okay. So what's that mean? Okay, so give you one example. Okay, for example, yeah, we have this molecule, right? 3 substituent group, okay. So yeah, 2 methyl, 1 ethyl, okay. So yeah, we can number it a lot of different ways, okay. So there are 2 ways, okay. So okay, we can have a relatively lower number, lower combined number, okay. So one way we can do this, okay. Start with this methyl ethyl group, okay. 1, 2, 3, 4, okay. Another way, okay, we start with this methyl, okay. 1, 2, 3, 4, okay. And lowest set number is kind of if you add all their the location number together, okay. The lower, not the right way to do kind of numbering, okay. So for example, okay, so if I try to do the black one, okay, black numbering, okay. So 1 is methyl, 1 is ethyl, 3, 4 is the 3, 4 kind of 2 methyl, okay. So if you add those numbers together, that's give 8, okay. But if I do the red one, okay, okay. So yeah, 1 methyl, 2 methyl, and then plus the 4 ethyl, that's give you 7, okay. So that's the smaller number than 8, okay. So that means we do the red one, okay, numbering, okay. So that means the lowest set of the number, okay. All right, 14 kind of just the straightforward, okay. So yeah, you put the all substituent group name and also location number, alphabetic order before the parent name, okay. So that's 4 ethyl, okay. So 1, 2, okay. So keep in mind, if you have the more than one same substituent group, okay. So you need to give their all location numbers, okay. And also the dimethyl, you need the label di, okay. And then this one is cyclohexene again. Okay, so that's keep in mind that different number of different number of substance group. Okay, you have the different way to the number the substance group. Okay. Okay, and the last situations is if there's a kind of a long carbon chain, okay, which has more carbons than the attached the ring system. Okay, so in this case here we name the carbon chain as kind of the partner name. Okay, and then cycloalkene attachment as a substituent case. Substituent case, so just kind of the change ANE to YL. Okay, but here the cyclo you keep in mind. Okay, you need count C. You need count C. Okay, right. So give you one example, you will understand what I'm talking about. Okay. All right. So for example, okay, so we try to name this compound. Okay, name this compound. Okay, right. So you can see there's a 5 membrane and there's kind of a long carbon chain. Okay, this carbon chain has 7 carbons. Okay, so in this case we will name the parent based on this long carbon chain because it has more carbon than the kind of ring. Okay, and then this 5 membrane becomes the substituent group. Okay. The substituent group is pretty easy. Okay, so that's just become kind of cyclopentene. That's become a cyclopental. Okay, change ANE to YL. Okay, right, and then list kind of alphabetic order. Okay, and with other substituent group, we have kind of another methyl group. Okay, right. So that should be the 5 cyclo. Pental, okay, so ANE become kind of the YL, okay, and then 2 methyl, okay. So when we number this carbon chain, we try to give a first second group lower number possible, okay. So if we go from right to left, okay, the first second group on second carbon, okay. If we go left to right, okay, the first second group on third carbon. So that's why I do this way, okay. 1, 2, 3, 4, 5, and 6, 7, okay. All right, and then that should be kind of the haptene 7 carbon. Okay, and so here just keep in mind, okay. So most time if you see some kind of di-tri sactet, okay. So don't need to count the alphabetic order, okay. But the cyclo, the C counts alphabetic order, okay. So the cyclo has kind of low alphabetic order than kind of M, okay. So that's you put this one before kind of the cyclopental before the methyl, okay. Yeah, so that's just something keep in mind, okay. Y and Y, okay, because this time the cyclohexene pentene become a substituent group, okay. Substituent group, okay, always ended with FIR, okay. So if you still put the ANE cyclopentene, okay, so people get confused, okay. So don't know which one kind of your main carbon chain, okay, main kind of parent name, okay. So don't know it's kind of haptene or kind of cyclohexene. It's kind of the main parent name, okay. So there's only one for you guys just keep in mind, okay. There's only one parent name, okay, parent chain or parent ring, okay. But you can as many as possible kind of the substituent group, okay, substituent group, So for the AQ always under with kind of YR, okay, yeah. All right, so that's right, okay. So if you have any question, type in chat window, okay. Okay, so little bit talk about the alkene kind of physical and also chemical property, okay. So alkene has only CC single bond and also CH single bond, okay. So both are kind of non-polar covalent bond, okay. So that means that's the only London force, okay, between the alkene molecule, okay. And the London force, we know that kind of weakest the intermolecular force, okay. So that's why alkene normally has a lower melting point, boiling point, okay, and also hydrophobic, okay. But if we increase the molecular weight of alkene, okay, so that's there will be a stronger the intermolecular force, stronger London force, okay, and then there's possible kind of change the alkene to kind of solid or liquid, something like this, okay. And here's kind of the basic trend for linear alkene, okay. So what's our kind of the phase, okay. So if it's only 1 carbon to 4 carbons, okay, so linear alkene, okay, so just a gas at room temperature, okay. Like a propane, okay, propane kind of we compress in kind of the can, okay, at kind of just burn something, okay. And so if it's the 5 carbon to 7 carbon, the linear alkene, okay, normally they are liquid, okay, at room temperature, okay. Yeah, for example, the gasoline, okay, so use it for a car, okay, or some kind of diesel, okay. So if it's more than 18 carbons, okay, so that should be kind of solid, okay. So example is wax, okay, so that's just solid alkene, okay. So for alkene, okay, so because only carbon-carbon single bond and so carbon-hydrogen single bond, okay, very inert, okay, so pretty much no reaction, okay, so that's what we call kind of unreactive, okay, so alkene also called kind of paraffin, okay. And so far the main reaction for alkene is just the burn it, okay, just the showed here, okay, so you have some alkene react with the oxygen, generate kind of carbon dioxide and heat, okay, generate kind of heat and also water, okay, so that's the main reaction, okay. So in organic chemistry too, okay, we will probably learn another reaction, radical reaction that's here that happen to alkene, okay. So but so far I don't need to worry about it, okay. All right, so we found the alkene name, okay. So now we move to alkene name, okay. So CC double bond kind of the compound, okay. Here. All right, so for the general formula of the alkene is the CnH2n, okay, so 1 degree on saturation, okay. All right, so the first thing kind of you need to tell people there's kind of a CC double bond in the molecule, okay. So in this case, so remember the saturated one we under the suffix kind of ANE, okay. So you need to change the A to E, okay. So lots of people know it's there's kind of the CC double in molecule, ENE, okay. And also you need to label the location, okay, for the CC double bond, okay, because there are kind of long carbon chain, okay. So you tell people where is kind of the CC double bond, okay. And another casing is kind of when you pick up the long carbon chain, okay, so you need to contain both carbon in the both carbon of your CC double bond, okay, in the long carbon chain, okay. So what's that mean? Okay, with one example, you will understand what I'm thinking. I'm talking about, okay. All right. So for example, this molecule, we try to name it, okay. Right, so long carbon chain, okay, looks like this straight line, okay, so that's 1, 2, 3, 4, 5, 6, 7, okay, 7 carbons, okay. But here this one we need to name as kind of alkene, okay. So in this case here when you pick up here the long carbon chain, you need to include both carbon, okay, of the CC double bond, okay. So that means here the long carbon chain should go this direction. So that's here, okay. So 1, 2, 3, 4, 5, 6 carbon, okay. So it's although it's kind of shorter than 7 carbon, but this long carbon chain contain both carbon of the CC double bond, okay. So that's actually kind of right naming, okay. So that's something keep in mind, okay. Contain both of the carbon in the double bond, okay. All right, and then 14 case, so we can go ahead kind of number the long carbon chain, okay. So when we number it, okay, so we try to give the CC double bond lower number, okay. So for this case, okay, so that should be kind of 1, 2, 3, 4, 5, 6, okay. And you also need to give their kind of location numbers for the CC double bond, okay. So just kind of first of the lower number of the CC double bond kind of for example, this is 1 and 2, okay. So that's you just label 1. That's enough. Okay. Don't need kind of label 1, 2 some alkene, okay. All right, and so if there's kind of the RQ group and also a CC double bond in one of the carbon chain, okay, so keep in mind, okay, so the double bond, okay, has higher priority than the kind of RQ group, okay. So in the numbering of your pattern chain, okay, what's that mean? Give you one example you will understand, okay. All right, for example, here. Okay, for example, this molecule, okay, right? So long carbon chain goes straight here, or if you from top to down, that's also fine, okay. All right, okay, so now we have long carbon chain, okay. So but here maybe mark for you guys, okay. Okay, So next kind of we need to number it, okay? So 2 ways to number it, okay? So from left to right or right to left, okay? So which is right, okay? So if you try to number it from the right to left, okay? So we'll put the RQ group, okay? This methyl group on second carbon, okay? But we'll put this double bond onto the fourth and also fifth carbons, okay? In this case, but if you want to number it from kind of the left to right, okay, we'll put the carbon C double bond onto kind of third carbon, okay? So although the C double bond is 2 bonds away from the left end, okay, but the C double bond has higher property than the RQ group, okay? So we try our best to give C double bond lower number possibly. And although the methyl group kind of only 1 bond away from right end, okay? So that's here, okay? Try to give the double bond lower number, okay? Because double bond has a higher property than kind of the single the kind of methyl group, okay? So that's what we do here. 1, 2, 3, 4, 5, 6, 7. Yeah. So that's how do we number, okay? All right, and so once we have the last carbon chain and the numbering, okay? So we can name the parent chain name, okay? The parent chain is just kind of similar like the arcing saturated one, okay? So just only thing just keep in mind, okay? So the ANE become kind of the ENE, okay? And also you need to label the double bond location numbers, okay? So because you need to tell people, okay, where's the double bond on the chain, okay? All right, okay, so here's the 2 example, okay? So both are built-in, okay? The first one double bond kind of at the first carbon and second carbon, okay? So you need to label it kind of 1 built-in, okay? And the second one, okay, so double bond on the second and the third carbon, okay? So you need to label kind of 2 built-in. In this case, people know, okay, there's a double bond in the kind of the chain, okay? Right, so where do you put the number? Okay, so there are 2 ways to do it. Okay, so the one way is kind of just put the location number of the double bond before the parent name. Okay, so 1 built-in, 2 built-in. Okay, another way, okay, so is put between the roots. Okay, that's root, built is root. Okay, and the suffix, okay, between these 2 guys. Okay, and both we are fine. Okay, so the nowadays case, so the second way is kind of more popular. Okay, so because the some situation, okay, the first way cannot give kind of a clear indication, okay, whereas kind of a second group, okay, or kind of whereas double bond, okay. Personally, I like the first way, okay, so put the number before the parent name, okay. Reason for that, kind of easy to pronounce, okay, so 1 built-in, that's it, okay. For second way, okay, so built 1 in, okay, so not easy to pronounce, okay. And but in the exam quiz, okay, both way are fine, okay. So I will give kind of full credits, okay. So if you either way is fine, okay. So either way, okay. All right, okay. And then in the end, okay. So if there's the substring group, okay, on the carbon chain, okay, you just put the location number, also kind of the substring group name, okay, before the parent chain name, okay. That's it, okay. All right. So for example, this one, okay. So that should be kind of octane, 2 octane, okay. First number of the C double bond, okay, and then you put 7 methyl before the 2 octane, that should be fine, okay. You can also name as name as kind of 7 methyl oct 2 in, okay, that's also fine, okay. Right. Okay, and then okay, so one more example, I will show this guy, and then you guys try to name the another molecule, okay, on the right, okay. So this one, okay, so 6 carbons, okay, should be the 6 hexene, sorry, okay, should be kind of 1 hexene, okay, 1 is the location number, 1 is the for the C double bond, okay. ENE, okay. All right, and then we add kind of substring group, okay, let's see the 2-ethyl. 2-ethyl, 1 hexene, okay. So you can also name it as the 2-ethyl, hex 1 in, okay, that's also right, okay. All right, okay, so now you guys take a try, okay, try to name the molecule on the right, okay. Yeah, you can write down your answer in the chat window, okay. So someone, if you like, okay, take a try, okay, write down your answer in the chat window, okay. Yeah, for the arcane name, okay, so just from the last carbon chain, okay, change the ANE to ENE, okay, and then make sure label the city double bond location numbers, okay, and then eventually put the all starting group, okay, before the just a partner tree name, okay. All right, anyone want to take a try? Okay, so name this molecule. Yeah, that should be 6-methyl. That's right. Yeah. All right. I guess students already showed the answer on the kind of chart. Okay. So this one, the whole carbon chain, okay, should be kind of 3 heptene, right? KP-ENE, and then we put kind of the methyl group before the kind of parent name, okay. So that's 6 methyl. Right. Okay. Good. Yeah, that's right. Okay. 6-methyl, 3 heptene. Okay. All right. Good. Okay. Okay, so here we will learn 2 more substituent group, okay, so name, okay, so we already learned kind of methyl, ethyl, propyl, whatever, okay. So here these 2 based on the alkene, okay, city double bond, okay. So one is the double bond, okay, connect with kind of CH2, okay, and then connect something else, okay. So this one we call kind of allele, okay. And then another one kind of double bond directly attached to something else, okay. So this one we call the vinyl, okay. All right, make sure you see the difference between these 2 guys, okay. So we're similar structure, okay. Allele has kind of the CH2, okay, and between the double bond and also some other main carbon GT. Vinyl directly attach kind of the double bond onto kind of something, okay. So give one example, okay. So So this one, okay, actually we can call it the vinyl bending. That's the bending, okay. So vinyl, okay. And but if there's kind of one more carbon, okay, between the double bond and also bending, okay. So like this one, okay. This one we can call the allele bending, okay. So see difference, okay. So there's one actual kind of CH2 here, okay. So that's actually kind of pretty important substituent group, okay. So make sure you know the difference, okay. We'll see this quite often in the future. All right, and then there's one situation kind of more than one double bond in the molecule, okay. So 2 double bond or 3 double bond, okay. So if there are kind of 2 double bond, okay. So the suffix name becomes diene, okay. So if there's only 1 double bond, just in, okay. But 2 double bond, okay, called kind of diene, okay. And the naming kind of actually not hard, okay. Just find the longest carbon chain containing all the kind of carbon of the double bond, okay. So for example, this case, okay. So you have kind of the last carbon chain go like this way, okay. So we are continuing all the 4 carbons of the 2 double bond, okay. Right, and then second kind of once you name it, okay. So this one should be the 5 carbon, okay. Penta. You need to add A, okay, between kind of penta, okay. So the suffix name and the root name, okay. So root's the pent, okay. Suffix name is the diene, okay. The reason for that kind of is easy to pronounce, okay. So if you don't have this A, okay, so the pentadiene, okay. So it's just kind of pentadiene. That's easier to pronounce, okay. All right, and then casings here, okay. So you need the give a location number for both the C double bond, okay. So you want to number the chain, okay, and give you the lower number for the actually the first carbon chain, okay, C double bond, okay. So that's for this case here, should be 1, 3, okay, pentadiene, okay. So we go from kind of right to left, okay. Right, in the end, just take care of the old substituent group, okay. So substituent group, okay, so should be the just methyl, okay. So on the 3rd carbon case, so 3 methyl. And that should be too hard, okay. And so again, okay, so if there's more than one C double bond, okay, so depends how many, okay. So if 2 double bond, okay, should call the diene, okay. 3 double bond, okay, should call the triene, okay. 4 double bond called kind of tetraene, okay. And make sure you label all kind of double bond locations, okay. So because people know where's all these double bond, okay. So quite often mistake, student only labeled 1 double bond, okay. So that's wrong, okay. also yeah, put a between kind of the suffix and also the roots. Okay, so just yeah for pronunciation. Okay, only for pronunciation. Okay. All right. And next is yeah nomenclature for the substitute kind of cycloalkene. Okay, so yeah. So there's some kind of double bond in the ring structure. Okay, so how do we name it? Okay, so that's actually kind of not hard. Okay, so if there's no substitute group, okay, so just kind of change the ANE to ENE. Okay, so cyclohexene, cyclopentene, something. Okay, and so yeah, you don't need a label the carbon double bond. Okay, so because the people already know there's kind of double bond. Okay, so yeah, but yeah, if there's the substitute group, okay, branch on the ring. Okay, so in this case, when you number the ring, you have to think about kind of the direction, okay, clockwise or counterclockwise. Okay. Give you one example. Okay, give you one example. Okay, so you will see what I mean. Okay. All right. So for example, this molecule. Okay, so fine membrane, and there's the double bond in the molecule. Okay. In the ring. Okay, and then there's kind of the methyl group attached to the ring. Okay. How do we name this molecule? Okay, so yeah. The whole ring should be kind of cyclopentene. We know, I know that. Okay. Right, cyclopentene. Okay. Right, and then yeah, how do we number it? Okay, because we need to give a location number for this the methyl group. For the theta bond doesn't matter. Okay, because they're always kind of carbon 1 and carbon 2. Okay. Right, 2 ways to number it. Okay, so one kind of do the counterclockwise. Okay, 1, 2, 3, something like this. Okay, another way is kind of do the counterclockwise. Okay, so yeah, 1, 2. Okay, let's go this way. Okay, right. So in this case, yeah, you have to find the direction. Okay, give something called lower number possible. Okay, so if we do kind of red one. Okay, 1, 2, 3, 4, 5. Okay, so yeah, the methyl group is on 5th carbon. Okay. But if we do the kind of clockwise, okay, 1, 2, 3, okay, methyl group will be on the 3rd carbon. So that's means the black one kind of right numbering, okay, right number case. Okay, we have the seven encounter first, okay, lower number, okay. Okay, so yeah, once you finish your number in the case of falling are pretty easy, okay. So it should be called kind of 3-methyl cyclopentene. Okay, don't need to give location number for the theta bond because the has to be take carbon 1. Okay, so has to be take carbon 1. Okay. Right, and yeah, so shows here. Okay, and here's another example. Okay, so yeah, just here the more than one substance. Okay, so yeah, so 3 substance okay, on the ring. Okay, and then also 1 double bond. Okay, so yeah, you want to give a low set of your numbers. Okay, so in this case, yeah, we number kind of 1, 2, 3. Okay, that goes this direction. If we go counterclockwise, okay, so yeah, the sexual group will be on the probably the 4th or 5th carbons. Okay, that's a bigger number. Okay, right. And so if there are more than one theta bond in the ring, okay, so in this case, yeah, you have to give a location number for all the double bond, okay, because the other people want to know where this double bond goes, okay. Okay, example showed here, okay, so yeah, we have the 2 double bond in the this 7 membranes, okay. And the one tricky thing is kind of this 7 membrane also has kind of this substitute group on it, okay. So in this case, yeah, when you number it, okay, so yeah, also come to problem. Okay, so how do we number it? Okay, the clockwise or counterclockwise? Okay, you can number this carbon 1, 2, 3, 4. Okay, also kind of number from this carbon 1, 2, 3, 4. Again, okay, so this time, okay, try to see which one gave a lower number for this substance group, this propyl group. Okay, so definitely kind of we number this carbon at 1, 2. Okay, so that's all. Sorry, the 2nd carbon. Okay. And then yeah, again, okay, yeah, that's also similar like the open chain one. Okay, so yeah, you need to put a between the kind of root name and also the suffix name. Okay, so yeah, that's become kind of the cycloheptadiene. Okay, one you also need to give the location numbers. Okay, 1, 3. Okay. And eventually 2 propyl. Okay, so yeah, that's little bit hard one. Okay, probably won't see kind of in the exam quiz. Okay, but yeah, just a little bit keep in mind. Okay. All right. Okay, so yeah, here's kind of one practice for you guys. Okay, take a try to name this compound. Okay, try to name this compound. Okay, so this one actually kind of pretty hard one. Okay, so yeah, this morning. maybe 4 or 5 students tried it, okay, so yeah, only 1 student gave right answer, okay. Yeah, if you like, you can type here the answer in the chat window. Okay, right. Just some hint, okay, so I guess some students got confused, okay, what's the ET means, okay? ET is abbreviation for the ethyl, okay. Yeah, quite often, when people draw the kind of structure of an organic molecule, okay, instead of they show the ethyl, the 2 carbons chain, okay, so you just kind of put ET here, okay, that's make sure you know the kind of abbreviation for the ethyl methyl something, okay. Methyl is kind of ME, okay. Anyone remember what's the name for this one? CC bond? We just learned it kind of maybe 2 slides ago. It's here. Vinyl, okay. So say someone directly touch with something, okay, so that's the vinyl. All right. So I think I gave you guys enough hint, okay, you should able to know the name for this molecule. All right. Pretty close, okay, so yeah. Anyone can come up with a better name? You draw that with ethyl shown out. All right, okay, so yeah, someone want me show kind of okay. Yeah, that's these two are same thing. All right, so also close, okay, but not exactly, okay. Keep in mind, okay, so if there's only one C bond, you don't need label location numbers, okay. All right, can anyone come up with the better one? All right, okay. I guess let me try it, okay. All right, for this molecule, okay. Okay, so definitely kind of these two we kind of substance group, okay. So and then we try to give the C bond lower number, okay. All right, so if we want to give C bond lower number, there are kind of 2 possible way to kind of number it, okay. One way kind of 1, 2, okay. So do the clockwise, okay. 3, 4, 5, 6, okay. All right, another way do it kind of counterclockwise, okay. So this carbon become carbon number 1, okay, and put 1, 2, 3, 4, 5, 6, okay. All right, okay. So the problem here is kind of if we use the red numbering, okay. So vinyl group will on the 4th carbon, and then ethyl group will be on the 5th carbon, okay. But if we use kind of red numbering, okay, so the ethyl group on the 4th carbon, vinyl group on the 5th carbon, okay. Both give pretty much similar number, okay. So 5 and 4, okay, 5 and 4, okay. Right. So that's kind of important thing kind of we learned in the previous class, okay. So if we both way to number it, okay, give the same number, okay. So both kind of 5, 4, okay. So you try to look at kind of which substance group has a lower alphabetic order, okay. So you try to give a lower alphabetic order, the substance group lower number, okay. So vinyl ethyl, okay. So definitely kind of ethyl group has a lower alphabetic order, okay. So in this case we use kind of red numbering, okay. So red will give kind of ethyl at 5 at 4, okay, and then vinyl at 5, okay. So that's way, okay. All right. So now we can put the name together, okay. 4 ethyl, 5 annual, okay. All right. So for cyclohexene, okay, so you don't need put the their location number or whatever, okay. So because there's only one CETA bond, okay. Yeah. So that's the right name, okay. Yeah. So some students already come up very close to answer, okay. Just a little bit wrong numbering case well, but yeah, that's fine, okay. Yeah. For ethyl 5-vinyl cyclohexene, that's the right answer. Okay, pretty good, okay, you guys. Yeah. This is the hard one, okay. Okay, so next to come kind of the alkyne, okay. Oh yeah, that's right. Okay, sorry, okay, should be hexene, okay. Yeah, not hex. ENE, okay, hexene, okay. Yeah. All right, okay, so that's right, okay. And now we move to the alkyne naming, okay. So alkyne has kind of a CC triple bond, okay. So general formula is the CnH2n minus 2, okay. And so there are 2 degrees on saturation, okay. So yeah, the name of the alkynes very similar to the alkene naming, okay. So yeah, just keep in mind, okay. So you need change the ANE to YNE, okay. So that tell people, okay, there's the CC triple bond in the molecule, okay. YNE, okay, YNE. And also similar to the alkene name, okay. So you need to pick up longest carbon chain contain both the C triple bond carbon, okay. And then when you number in this carbon chain, okay, so you try to give the lower number for the C triple bond, okay. And then number the carbon chain to give the first carbon of the C triple bond the lower number, okay. And then just when you give the full name, okay. So make sure that you label the C triple bond the location numbers, okay. Right, so example showed here, okay. So first one is the longest carbon chain containing both carbon of C triple bond. That's here, okay. So 4 carbons, okay, and then butane, okay, butane, okay. You need to give a location number for the kind of the C triple bond, okay, and then the C triple bond has higher priority than kind of methyl group, okay. That's we give kind of C triple bond lower number, okay. So the 1 butane, okay, and then 3 methyl, okay. Right, and then second one is kind of the longest carbon chain, okay, like this way, okay. So 7 carbons, okay. And we try to give a lower number for C triple bond, okay, than this 2 methyl group, okay, because the C triple bond has higher priority, okay. So although these 2 methyl group only 1 bond away from the right end, okay, but C triple bond higher priority, okay. So yeah, that's why kind of 3, okay, heptane, okay, and then eventually put the name and also location number for this 2 methyl group, okay. That's 6,6 dimethyl, 3 heptane. Okay, so now again, you guys take a try, okay? So try to finish these 2 questions, okay? So these 2 actually kind of the 2 common types of questions you will see in the future exam, okay, and quiz, okay? The first one give you name, okay? Ask you draw a structure, okay? And second one give you structure, ask you kind of the name it, okay? So yeah, just text the name, okay? Right, again, okay, so yeah, if someone want to be volunteer, okay, so you can turn on the annotation, okay, so the draw the structure, okay, on the screen for the first question, okay, so this one, okay, yeah, and then for the second one, okay, so either way, okay, you can the type the name on the kind of screen or kind of type the name in the chat window, okay, either way is fine, okay. So this morning, okay, so some students quickly come up constructor for the first question, okay, so second one kind of it's kind of the tough, okay, so all right, someone want to take a try, okay, draw the structure, okay, for the first one. Yeah. Okay, I saw the CC triple bond, okay, good. All right, let me see. 1, 2, 3, 4, 5. Okay. All right, actually pretty good, okay. Only thing kind of one thing need to remind, okay, so for the CC triple bond, okay, so you need to show the bond angle 180 degrees, okay. So here you see, okay. So you cannot draw the kind of banded bond, okay. Yeah. Can someone try to kind of the people draw the structure, make a little bit of correction? Yeah. Okay, I guess that should be right. Okay, right? So 180 degrees, okay? So yeah, that's pretty good, okay? So the first one, okay? Actually, kind of, yeah, same thing, okay? Just here, that's pretty good one, all right? Okay, so someone try the second question, okay? Try to name it, okay? Yeah, you can, okay, someone already typed the answer in the chat window, okay? So this is the little bit hard one, okay? But if you still remember the right way to number it, okay? So should able to do it, okay? Yeah, someone put answer here, okay? Several problem, okay? So keep in mind, okay? The CC tree bond has higher priority than any RQ group, okay? So when you try to number it, okay? Oh, okay, that's very close case. Someone in this morning also gave this answer, okay? Can anyone come up a little bit better one than this one? Okay, because of time limitation, okay, so I will just show what's going on, okay? Right, so some students kind of show the answer, okay, so actually kind of pick up this carbon chain as the main carbon chain. Right, that's actually there's nothing wrong with this one, okay, because that's kind of 7 carbon, okay, 1, 2, 3, 4, 5, 6, 7, okay, and but there's another possibility, okay, so use a different. You can also do like this. Yeah, the blue one, actually kind of the green one, okay. Right. So here also can give you kind of 7 carbons, okay, 1, 2, 3, 4, 5, 6, 7, okay. Right. So that means kind of the 2 ways can give you the same number of the carbon, okay, which is right, okay. So keep in mind, okay. So if you have 2 ways can give you same length of carbon number chain, okay, you want to pick up the carbon number chain, okay, okay, with more substituent group, okay, more substituent group on it, okay. So if you do the red one, okay, so only 1 substituent group isopropyl, okay. But if you do the blue, green one, okay, there's 2 substituent group, okay. More substituent group, that's better, okay. Yeah, now it's right, okay, yeah. Okay, so the once you have this one, okay, so that should be So do it backward, okay? So first put kind of parent name, okay? So it should be kind of 2, heptene, okay? And then methyl ethyl, okay? So alphabetic order before the parent name, okay? So it should be kind of 5 ethyl, 6 methyl, 2 heptene, okay? So that's the right name for this compound, okay? But you guys already did a pretty good job, okay? All right, okay, so that's down the class today. We will continue this chapter on Monday, okay? All right, thank you. Have a good weekend, everyone, okay? Do we have a test? No test on Monday, okay? Nothing on Monday, okay? Monday, we still need to finish this chapter, okay?